Dr. Jani Radebaugh is an associate professor of geological sciences and is a planetary scientist. Her research centers on geological processes on planetary bodies, including our own planet Earth. As an associate team member for the NASA Cassini Radar Instrument Study, Dr. Radebaugh works with other scientists to determine the origin and evolution of landforms on Saturn's moon Titan. She and her students are actively researching the mountains, sand dunes, river channels, and wind-carved ridges of that moon. Professor Radebaugh and her students study volcanoes and mountains on one of Jupiter's moons from data collected in the Galileo, Voyager, and Cassini missions. She does field work in the Sahara, the United Arab Emirates, Namibia, Ethiopia, Vanuatu, and Hawaii, all locations on Earth that have similar landforms to those seen on other planets. She has served as a field party member for the Antarctic Search for Meteorites program, once taking a leadership role in field deployment operations. Dr. Radebaugh is a leader in space science, serving on several NASA panels and advisory boards. She has appeared in the Discovery Channel's How the Universe Works series several times. She is a regular speaker at the Space Fest convention, and she recently delivered a TEDx BYU talk about exploration. Dr. Radebaugh enjoys interacting with large numbers of BYU students and with the general public about space.
Thank you very much. A couple of years ago, I went on a journey, a geological expedition to one of the most remote locations on the planet, the Afar Rift Valley of Ethiopia. It took us 3 days to get there from the capital city of Addis Ababa. We first flew to the tiny outpost town of Mekelle, where we landed on a dirt runway, my first dirt runway. And we all piled into land cruisers and drove off across the high plateau. We continued east until we arrived at a deep and wide chasm, like a larger version of our own deep and dramatic Death Valley in California. And we plunged the 7,000 feet down to the valley floor. We passed long trains of camels laden with salt from mines that they had mined it from in the north of the valley. Our guides told us that the camels and their drivers carried the heavy salt up from the valley floor, across the plateau, over to the village, and then back down again, day in, day out, for most of their lives. We slept that night in a makeshift camp with tiny huts, all stretched out across rope-strung cots under the hot, dry desert breeze. It's my favorite way to camp. The next day, we drove off across the dusty, bumpy valley floor, past salt flats, fields of sand dunes, across wide wadis where people and animals obtained what little water they could from the dry desert. After all day driving, we finally arrived at the base of our destination, a large, broad shield volcano called Erta Ale, which signals the opening up of the Afar Valley, eventually to become part of the ocean floor like the adjacent Red Sea. We paused at a village on the flanks to parley with the Afar chief and the village leaders for permissions and for guides to access the mountain summit. Finally, in the cool of night, under 95 degrees instead of 105, we made our way up the mountain. And we were tourists and scientists and young Ethiopian guides from the city and Afar village escorts and camels, and we paraded up the hill. And it was very dark and it was hot and windy. We finally arrived at the summit, and I could see off in the distance a deep red glow. We scrambled down the steep walls of the summit depression or caldera and made our way across the tangled lava flows of the crater floor, some of which shone so glassy and bright in my headlamp that I knew they were just weeks old. Finally, we crested the lip of yet another small crater, and I saw this beautiful lake of lava. You can hear the wind blowing, sending waves of hot gases and heat that almost overwhelmed us. Just last year, I found myself gazing into another lake of lava on a jungle Pacific island called Vanuatu. And this lava lake being absolutely roiling and incandescent. even at hundreds of feet down, it was too bright for us to look at. Soon you can hear the sound of the lake itself over the wind. You can hear in the words of our mountaineer Pepe that it is hard to describe what it's like to witness the creation of new land. Why would we undertake these kinds of expeditions as scientists? Events that take time and effort and resources at some amount of risk? Why don't we rely solely on reading papers or thinking about the problem, studying images, or doing lab work? Why do we think it's scientifically valuable to go out and observe the geology in action? Well, first of all, we love the adventure, don't we? We hear these kinds of stories and we think, I have got to do that. But we might ask ourselves, why do we think that of some place that is so hard to access? What is it about the human spirit that makes us willing to sleep on rocky ground, to bear the heat and the cold and the hunger, and actually relish that experience because we know we're seeing this amazing thing? We explore so that we may discover. We understand as scientists that we can learn more about our natural world simply by exploring it. So we endure and maybe we even enjoy the hardship that comes along with such an endeavor. But why lava lakes in particular? Our beautiful Vanuatu lava lake, down below view to the lower left, would constantly illuminate billowing clouds of steam and smoke that rose up from the lake. During a rare break in those clouds, I happened to see, peeking through like a bright star, the planet Jupiter. If we zoom in, we can see a view caught by the Cassini spacecraft of our big brother. Jupiter has beautiful bands of clouds that encircle the equator and Earth-sized storms. And hovering above the cloud tops like a jewel is the tiny moon Io. It's the same size as Earth's moon, but there are a lot of differences. You can see even from this distance that the surface has many different incredible colors. It's these colors and the proximity to Jupiter that told us, even before spacecraft like Voyager and Galileo arrived to reveal the surface in detail, what we should see there, and that is hundreds of active volcanoes. There are long, dark lava flows, tall plumes of gas and dust, some of them hundreds of miles high in the low gravity and the thin atmosphere. And brightly colored deposits of sulfur in yellows and reds and greens. All of these volcanic materials have come from the inside of Io because of the relentless tug of Jupiter's gravity massaging Io. Many of the volcanic eruptions are expressed as lakes of lava for reasons we are actively trying to understand. You can see perhaps a dozen lakes of lava in this image. It's round, dark circles and half circles. And in a few other images similar to this one, and in a handful of others at slightly better resolution. But this is all we have for Io, because it is very far away and it is difficult to reach by spacecraft. So we go and study lakes of lava on the Earth, where we can walk around on the lava flows and measure their thickness. We can stand at the edges of lava lakes and obtain temperatures, which tells us what the magma is like and what it is made of. We can watch their behavior over time to help make predictions, and we can use all of these observations paired with models that we test in the laboratory, models that students have built and are working on, and take that understanding and apply it to Io. Similarly, we can look at lava lakes on Io, some of which are so large that they're the size of the Great Salt Lake. And we can think about a time when the inside of Earth was so hot that there were lakes of lava that big on Earth. There no longer are today. So Io is telling us about our history. This is how we are learning about the solar system. We have a strategy that pairs pure scientific exploration with scientific discovery. Planetary scientist Torrance Johnson says that when we keep exploration at the forefront of all we do in space, then we are captivated, motivated, and committed. There is a certain ingrained charm in this approach. Another famous planetary scientist, Carl Sagan, reminds us that we were wanderers from the beginning. Even though we've generally abandoned the nomadic life, the sedentary life has left us edgy, unfulfilled. Even after 400 generations in villages and cities, we haven't forgotten. The open road still softly calls, like a nearly forgotten song of childhood. We are drawn by a craving we can hardly articulate or understand to undiscovered lands and new worlds. Like this one. Where's this? Last week, the New Horizons spacecraft flew past the most distant planetary bodies yet visited in our solar system, Pluto, and its underworld moons Charon, Nix, Hydra, Styx, and Kerberos. It took 9.5 years, flying at 36,000 miles an hour, 60 times faster than a jetliner, from when it was launched off of Earth on a massive rocket to arrive at Pluto, 3 billion miles away. And the images we have of that distant, almost starlit surface are breathtakingly beautiful, and they've left us scientifically awestruck. There are regions full of mountains, some of them as tall as the Wasatch Mountains behind us, and probably made of very cold and hard water ice. Ice is a rock this far out in the solar system. The mountainous regions are provisionally called Norgay and Hillary Montes, named for the Nepalese and British explorer pair who first summited Everest. The smooth plains are ice caps of atmosphere, frozen solid, methane, nitrogen, and carbon monoxide. It is 30 degrees above absolute zero on the surface of distant Pluto. So these are cold glaciers of a wholly different kind of ice, flowing around on the surface, filling and covering older areas that are pockmarked with craters, like in the dark regions on the west, a remnant from way back when many objects were whizzing around the solar system and smashing into each other. Pluto's largest moon, Charon, has long chasms that are miles deep. Why? Why mountains and chasms and glaciers? These bodies are too small. They should be cold and dead and cratered. We did not understand how planetary bodies, including Earth, change and evolve and lose the heat they have inside of them as well as we thought. We didn't know that until last week. So now we have to go back and rethink those ideas for all the bodies in the solar system all over again. Imagine being on the New Horizons team, having worked and waited for at least 15 years to get to Pluto, and now seeing that, first of all, everything worked, thank goodness. And those beautiful images are appearing on your computer screen, and you are the first people to see that amazing alien landscape for the very first time. All of this happened because we decided to go. If we did not commit to the expense and effort of flying a spacecraft all the way to Pluto, we would not know any more about the surface than what the Hubble Space Telescope provided us in images like this one, so blurry, indefinitely. This is the best we can do from Earth. But now, whenever we think of Pluto, this will appear in our minds with love. A body rich with interesting geology, with chasms and mountains and an atmosphere and a heart-shaped ice cap. Just seeing or visiting a place for the first time can completely change how we think about it. The arrival of New Horizons at Pluto marked the 50-year anniversary of the Mariner 4 spacecraft's arrival at the planet Mars. There was a lot of excitement surrounding this event because observations of Mars by telescope that were pretty poor in resolution had given us tantalizing hints of color differences that could be vegetation, of lines that crisscrossed the surface that might be canals. It was the beginning of the space age and the height of the Cold War, and from the mouth of one who was involved at the time, interest was intense. The first of just a few kilobits of images in total returned by Mariner 4, can you imagine that? Showed us a surface that was dry and dusty and cratered. There were no forests or canals, and the promise of life receded to small, isolated locations or buried underground. Our disappointment in the prospects for a more captivating Mars was palpable and lasted for decades. We have since been back to Mars in force with orbiters, landers, and rovers, and we have seen that our close neighbor is a much more interesting place once again. So we should remember that places, perhaps like people, bear a second and a third and a fourth look to truly understand them. When we prioritize exploration, then we are inspired, and new and valuable discoveries can occur. This image of Saturn is inherently so beautiful, but it becomes even more incredible when we think about how it had to be obtained. We had to have been sitting on the other side of Saturn, looking back toward the Earth and the Sun, so that we could see the sunlight shining through the atmosphere and the rings, illuminating them. So it is impossible to have obtained this picture from the Earth. And now we feel like we're on a voyage with a Cassini spacecraft around the backside of Saturn, looking back toward the Earth and seeing it with our own eyes. A really good reason to explore the Saturn system is to learn more about the largest moon, Titan. It's a little bit larger than the planet Mercury, about a third the diameter of Earth. In this picture, you can see sunlight shining off the surface of liquid methane, a giant North Polar sea called a kraken. At Titan's distance from the sun, 10 times as far away from the sun as the Earth, methane is a liquid, not a gas. But since we've just talked about Pluto and you're an educated audience, I should say methane is a liquid, not an ice. It gets very strange out in the solar system very fast. The methane on Titan forms clouds, and it rains on the surface, and it fills up rivers and seas. Sunlight is diffuse in this image because the atmosphere is very thick, with a haze made of organic materials like benzene and propane and ethane made high up in the atmosphere, and with a pressure at the surface just like Earth's. There is no other body in the solar system that can claim that. So now we have rainfall, rivers, lakes, seas, organics, and an Earth-like atmosphere. And suddenly Titan is a very compelling place for us to study. There are also vast fields of sand dunes. They appear dark in this radar image because sand is very fine, making the dunes smooth to radar, similar to how dunes on Earth look to radar pictures. And there are other similarities with the mega sand dunes of Earth. They are half a mile wide, hundreds of miles long, and they collect into vast seas of sand. Sand seas, where would we get this terminology? We've been applying it to Earth's big deserts ever since scientist, explorer, Colonel Ralph Bagnold visited Egypt and Libya during World War II. He conducted espionage with his long-range desert group by driving through the deserts in his Model A Fords and his Chevy trucks, up and over sand dune upon sand dune, off into the distance like waves on an ocean. He brought back valuable information about sand dunes that we still reference in the scientific dune literature to this day. When Colonel Bagnold was asked how he intended to get to Libya from Egypt, he said, "Straight through the middle of the sand sea. It is safe because it's believed to be impassable." He went out into the desert because he had to, but he returned with knowledge. Well, these are the new explorers. Following in the footsteps of Ralph Bagnold, field-worn and rugged, they are students, just like you. Now their cars are Land Rovers, though sometimes they can still get stuck. They have more sophisticated instruments that can help them measure the layering deep within the dune, which can tell us what the dune is made of, how old it is, where it is moving, and what will happen to it in the future. They are learning that these dunes are special. They're created thousands of years ago during the last ice age, behemoths resistant to change. Yet the students are still measuring their slow movement and studying the effects of changing wind and climate in the big desert dunes of North Africa, of here in the United Arab Emirates in the Saudi Peninsula, and in Namibia in Southwest Africa. The students are applying this understanding to sand dunes on Titan, for which we have only a few dozen low-resolution pictures. And once again, we can look at the vast sand seas of Titan that encircle the globe, unhindered by vegetation or by global oceans, in equilibrium with slow and steady winds, and we apply that understanding to the dunes of Titan, much more restricted in area and subject to rapidly changing winds and climate, to Earth, dunes of Earth. So Titan is helping us understand Earth. Drink of water. One place that perfectly blends Earth exploration with discovery in space is the deep field of Antarctica. Somehow it's in the cards that we must go to the most remote location on the planet, the place most difficult to access in every way, the place most challenging to live and survive in order to find the biggest collection of pieces of rock from outer space. The meteorites of all sizes and shapes and origins from near the Earth, from the asteroid belt between Mars and Jupiter, and even from the surfaces of the Moon and Mars, fall evenly all over Earth. So you could find one in your garden. But in Antarctica, they are concentrated by the giant continental glaciers over hundreds of miles to collect into piles near the bases of the mountains. It is a treasure trove of specimens from all across the solar system. These rocks speak to us of our origins, for they are siblings of Earth. When we find each rock, and we find hundreds each 6-week field season, I silently take a moment with it all by myself. I maybe talk to it for a second. I try very carefully not to snot on it and contaminate it for science. That's a real thing. And then I jump up and down and I wave and I do a meteorite dance. Everyone's required to do a meteorite dance. And get the attention of our field companions, and everyone rushes over. We take pictures, we celebrate, we make notes, and we wait for many months or even years. We collect the rock too, carefully, to find out exactly where it came from, because we don't bring the bulky and expensive equipment to study these things out in the field. We just look at it with our eyes. The meteorites we collected in 2013-14 are only now being analyzed at NASA because of a storm that broke up the ice dock before the ship could be loaded, because it takes a long time to sail across the world with all of the materials. It's hard to drive across the country and take a long time to prep and analyze the samples. But as I've said whenever I've gone, I am sure our meteorites will blow everyone's minds. I know it just by looking at them. Can you imagine gazing at a rock that has come from the moon or from Mars? Such rocks had to have been launched off of their parent bodies by a cosmic collision, an impact with another body, after which they drifted through space until they eventually reached Earth's surface, and we can hold them in our hands and look at them with something to protect it. They are basically free samples. It is vastly, achingly beautiful in Antarctica. There is no vegetation, there's not even lichen in the deep field. And the sun is always up in the summer, shining off the blue ice and the distant peaks. We dub the small mountains we climb after whichever of us crests the summit first, because we're probably the first people to have been there. Mount Radebaugh unofficially resides in the Davis-Ward Nunatak. Even if I've spent 40 days in the field, when I hear it's time for us to pull out, I go outside, I stare across the giant, brilliant white glacier under the low sun. I look in the direction of the South Pole 300 miles away, and I cry. Such vastness, such wide horizons and forbidding environments evoke strong emotions. Alexei Leonov, a Russian cosmonaut, was the first person to exit his capsule and walk in space. Of the experience, he wrote, "What I saw as the hatch opened took my breath away. The sky beyond the curving horizon was dark, illuminated with bright stars. Lenin once said that the universe is endless in space and time." It is the best description of what I saw in those moments. With a small kick, like from a swimming pool, I was walking in space. Nothing will ever compare with the exhilaration I felt in that moment. I felt the power of the human intellect that had placed me there. I felt like a representative of the human race. I was overwhelmed by these feelings. Well, this important moment was not without cost. The rest of their mission was full of hair-raising problems. First of all, he couldn't re-enter the capsule because of his bulky suit, so he had to let some oxygen out, which of course is very dangerous, so that he could squeeze back in. After jettisoning the airlock once he was inside, their spacecraft started to roll. The automatic landing system was not functioning. The communications cable with the orbiting and landing modules was still connected when they entered the atmosphere, so they experienced 10 Gs of acceleration on entry. You get about 2 Gs on California Screamin' roller coaster, just so you know. So the blood vessels in their eyes burst. Finally, all was quiet as the chutes deployed and they sailed safely down to Earth. And then they landed in 6 feet of snow in Siberia against a tree, so they had to rock their spacecraft back and forth to open the door and get out. Leonov's spacesuit was filled up with sweat up to his knees because of his exertions getting back in after his spacewalk. And as dark fell, it started to snow, and temperatures plummeted to minus 20 degrees. The helicopter pilots could see them, but they couldn't reach them through the trees until the next day. And they later told them that wolves were headed towards them. Space exploration is hard. The Apollo human missions to the moon were, of course, happening at the same time as Leonov's missions, as the U.S. and Russia were locked in a space race. 6 U.S. Apollo missions landed on the moon with people between 1969 and 1972, some of them within just months of each other. 12 people walked on the moon during this time, and none have since. At first, the missions were intended to be evidence to the Russians that we had the technology to reach the lunar surface, and to be the first ones to get there with humans. But the follow-on missions had a very strong science bent, led in large part by the astronauts who'd been field trained in remote analog environments on the Earth, like Iceland, a meteor crater in Arizona, and the Pinacate volcanic field in Mexico. Here is Apollo 15 Commander Dave Scott in the middle with a laser rangefinder, flanked by astronauts Jim Irwin and Joe Allen in front of a lava flow in New Mexico in 1971. Though initially trained as test pilots, look at them, don't they just look so cool? They caught the fever of scientific exploration, and they wanted to return valuable information about the moon. Dave Scott is here working with experiments during a lunar rover excursion in his field area of Hadley Rill on the moon. He speaks of finding a rock they had been looking for, the Genesis rock. This would be from the lunar highlands, the bright white mountains of the moon that you can see when you look up at night, made of crystals called feldspar that should be very old, perhaps dating back to the time of the formation of the moon. As he was walking along, his eye caught a bright white rock, and he could see the feldspar crystals, the twins gleaming in the sunlight. Now, this is a converted geologist. Heart racing, he picked it up, he turned it over in the sun to get a better look, convincing himself that this was indeed the Genesis rock, and he dropped it into his bag. Doesn't this just make you feel like you're there when you hear this story? It was the Genesis rock, and it turned out to be of great importance at finding the age of the moon and Earth, now refined to 4.567 billion years old. The astronauts did and learned a tremendous amount in the short few days that they spent on the moon, and all of the people who supported them. I feel a real kinship with Commander Scott when I hear these stories. Not to make it sound like my experiences even remotely approach his, but I loved to hear that suiting up to go out from their capsule to outside on the moon took them 2 hours. That's what it takes us to get suited up to go outside in Antarctica. But I have to admit that that includes the time it takes to eat copious amounts of bacon and chocolate so that we can stay warm for the rest of the day. Scott also says that after 3 dizzying days at their field site, when he pulled himself up onto the ladder of the lunar module for the last time, he paused. He felt the pangs of having to leave because he felt certain that no other experience would compare with those 3 days on the moon. He gazed out across a magnificent moonscape where sunlight on the crystal clear features contrasted with the rich blackness of the sky. He said, "I knew even then that I would never be coming back to the moon. I knew in those moments, all I knew was that I had come to feel a great affection for this distant and strangely beautiful celestial body, in effect a small planet, constantly circling our own." Just after arriving home from Apollo 15, Scott quoted Greek historian and philosopher Plutarch, "The mind is not a vessel to be filled, but a fire to be lighted." I absolutely believe that to be true, especially in the context of working with students. And I believe the best way to ignite this fire in you is to bring you into the field. I may go into the field with my own ideas and goals for what I want to accomplish there, or what I think is important to see, but you bring your knowledge and understanding, your own experience, and you see things that I didn't. You bring a new light to this work that I'm doing. We hope that as we go out and explore, we bring with us an open-mindedness so that we can be ready to discover. we go to places like this one, all geologists, in the foothills of the mighty Himalaya, students like you. And in the Himalayan foothills, you're already at 10,000 feet and gazing upwards. We come here for the geology, to see rocks that were once 50 miles deep thrust up to form the tortured ceiling of the earth. But the treasures we find in India, up in the canyon of the holy and revered Rishiganga, the headwaters of the Ganges, are more than ancient and mineral. They are human. They're our brothers and sisters of cultures and backgrounds worlds apart from us. They give us their love and a little piece of their experience to help make us richer. And they are beautiful. And we think of them as so lucky because they get to live in such an incredible place. They get to live next to a lake of lava. But I'm sure they appreciate this place for other reasons. Like the tourists in central China who go out to the desert to see tall pillars and hoodoos that look to them like ships or like sphinxes. They appreciate the stark beauty of the landscape. When we go as scientists, we see a different kind of beauty. We see wind-carved ridges that are ephemeral. And we feel lucky to see them because we know they disappear quickly. And we wonder if they're analogs for similar kinds of features that we see on Venus and Mars and Titan. And we imagine a time when we might actually be able to go out there and see those things from the field. This is so compelling because it speaks to us of possibility. It tells us what can be. But we have to remember we're already doing this right here on our own unique and special planet Earth. What talk is complete without a quote from Mark Twain? 20 years from now, you will be more disappointed by the things you didn't do than by the ones you did do. So throw off the bow lines. Sail away from the safe harbor. Catch the trade winds in your sails. Explore. Dream. Discover. Thank you.